In this video we're going to learn how to differentiate a product. We'll only do it with polynomial factors at this point, but as the course goes on we'll see how to do it with more and more complicated terms. We go through three steps. First we identify the factors, then we differentiate one factor while keeping the others the same and multiply them together. Then we differentiate the other factor while keeping the other ones the same and multiply them together, and we add those two terms together. At the end of the video, after the conclusion, I'll also give you a proof for why this works. So now for our steps and example. I've mentioned them just before. So differentiate the first factor and multiply it by the second. Differentiate the second factor and multiply it by the first. Add the two parts together. So here's our example. Y equals 3x squared plus 5 as our first factor, multiplied by 4x cubed minus 5 for our second factor. Now just at the side, if we differentiate 3x squared plus 5, we get 6x. And if we differentiate 4x cubed minus 5, we get 12x squared. So to get our solution, dy by dx equals the 6x that we got from differentiating 3x plus 5 multiplied by our second term, 4x cubed minus 5, plus 12x squared, which we got from differentiating our second term, multiplied by 3x squared plus 5, which is our first term. In the description below you can find a link to a worksheet that has questions that you can try on your own. I hope you found this video helpful. Staying in field with Winfield. Okay, so now for the proof that I promised you at the beginning of the video. So we've got y as a function of x, and that's made up of the product of two factors, u of x and v of x. So we've got f of x, now we want f of x plus h. So now we've got f of x plus h, we can use differentiation from first principles to get dy by dx equals the limit as h goes to 0 of f of x plus h, and we've got our form, minus f of x all over h. What I'm going to do now is I'm going to add in two more terms. It looks quite complicated, but if I do this you can see the two terms that I added. I've got minus u of x times v of x plus h plus u of x times v of x plus h. So they cancel each other out. And it's just a little trick that helps us get where we want to go. So I'm now going to factorise the first two terms and factorise the second two terms. From the first two terms I'm going to take out v of x plus h. From the second two terms I'm going to take out u of x. So I get this. Now they're both being divided by h, so I'm just going to rewrite this again. And I get this. Now you can see that what I've done there, I've taken the first factorised expression, the second factorised expression, and I've put the second part of it, each of those over h. Now if you remember what we did when we did differentiation from first principles, u of x plus h minus u of x all over h, as h tends to 0 and goes to the differential of u of x, or as we sometimes say, u dash of x. And obviously on the other side we're going to get v dash of x. Now as h goes to 0, v of x plus h goes to v of x, and obviously u of x stays as u of x. So that gives us dy by dx equals u of x times u dash of x plus v of x times v dash of x.